Greetings and welcome to Chapter 1, Sampling and Data. We're going to focus on Section 1.2, Data, Sampling, and Variation in Data and Sampling. First things first, go through the terminology for this section. Click on each of the words to become familiar with its definition and meaning. We're going to focus in on two types of data, qualitative and quantitative. Qualitative talks about kind of the characteristic of the data. So it might be something like a blood type or an ethnic group or even your hair color. Versus qualitative are always numbers. So maybe it's your pulse rate or the number of degrees that engineering majors get, or even the population of a country like the United States. Now, quantitative comes in two varieties. There's discrete, where you get to count them 1, 2, 3, 4, 5, and then there's continuous. Continuous deals with every fractional portion of a value. So it's not just 1, 2, 3. It could be 1.1, 1.2, 1.3. Let's take a look at a couple of quantitative examples and try and figure out if they are discrete or continuous. For the first example, the data are the number of books students carry in the backpacks. You sample 5 students. 2 students carry 3 books, 1 student carries 4 books, 1 student carries 2 books, and the last student carries 1 book. Now, would that be discrete or continuous? The data for the second example are the weights of the backpacks with the books in them. You sample the same 5 students and weigh their backpacks, and you get 6.2, 7, 6.8, 9.1, and 4.3. You notice that the backpacks in 3 books have different weights. Would this be discrete or continuous? Now let's look at the answers. The number of books, the 3, 4, 2, and 1 in the first example, are discrete data. They're countable. The weights are continuous data, so quantitative continuous data. Tables are a good way of organizing and displaying data, but they could be pretty limiting on how we can better understand the data. So we have some graphical representation that we can use. One is a pie chart. You've probably seen one of these before. It's a circle and each little wedge represents part of the whole thing. So they're really great at representing percentages or proportions. Bar graph are using the length of the bar to represent the numerical amount of the item or even a percentage of the item. The longer the bar, the more there are. Now, a Pareto chart is a bar chart, but it's very particular. It is ordered by largest to smallest. There are lots of other ways of displaying data. We're going to focus on a handful of them. The key to any statistics is gathering information. Now, it would be great if we could grab the information for the whole population, but most of the time that's just not possible due to cost. And therefore, we're going to take a sample. And even better so that it would be a random sample. And here's why. If we chose the item or the person that was involved in our survey, then the data could be skewed by who we decide to select to be into our survey. But if it's randomly chosen, then there's a better opportunity for our data that we collect to represent the whole population. There are many sampling techniques. This is your chance to explore each one that we're going to discuss. Simple, stratified, cluster, systematic, and convenience. Click on each of the titles to display an explanation of each of the techniques. When we're selecting a candidate through random sampling, we can do it with or without replacement. With replacement means that, let's say we have 100 people in our population, we randomly select one person and pull them out of the population. And maybe we gather some information from that person. And then when we're done, we put them back into the population to bring the population back up to the 100 people that it started with. That's with replacement. Pull a person out, ask them some questions, put them back into the population. With replacement gives you an opportunity, or there is an opportunity, to select that same person again. So you have to be aware, if you're putting the person back in there, there is a possibility that you will select them randomly again. Without replacement is you go to your 100 people of population, you randomly select one person, and then when you go to select another person, you do not put that person back into the population. They have already been questioned, and they are now out of the population, and you get to select a new person from the 99 people left in the population. You've reached the end of this lesson.